Why do downlights have a heatsink? Yep. I get this regularly. And it's because somebody would say, I've got a heatsink, I want to remove it because I can't fit it under a beam or something like that. I want to take the heatsink away. Why is it there? Why is it so big? Why does it look like it does? Because it looks terrible. Heatsinks are there for a reason. That light that I showed before, those LED chips in there generate heat. I have to dissipate that heat. Right, if I was to put fans all around it to keep it cool, great, but you're going to end up with a 90mm downlight that's about 250mm square because we're going to have to cool it down, right? But having that just on top of it like that dissipates the heat, which means that can go up and under your beam. All right, it's thick enough that it'll fit underneath a truss or something like that. So, but that has a heatsink on it. But in here, there is no driver. The driver's remote. Right, so that it doesn't have to dissipate the heat of the driver. So what they do is, by having a good quality heatsink, and cast aluminium is always a really, really good heatsink, which is that. Pressed aluminium is not so much a good heatsink, it's too thin, it can't dissipate the heat quick enough, and things like that, whereas that can absorb quite a lot of heat. Also prolongs the life of the LEDs, because it's taking the heat away and gives you a better light output and a longer light output. Some plastics can act as a heatsink when you have a driver on board. So your whole light is just one unit, right? When you look at that, there is aluminium under that plastic, and that aluminium is what dissipates the heat, and normally there's vents in the plastic to allow the heat to escape. Okay, so wherever there are LEDs, there is always a heatsink. The heatsink shape and the heatsink finish all have a factor. Okay, so this one here is just grey, but you can see the circles of actual heatsink. So that creates a bit of a vortex of cooling. All right, some of the others, they have the big fins all the way around. So when you look at this here, when you look here, this is our 2030, C2030. You can see the big fins on the back. This is a driver on board fitting. You can see it has vents. Here is just a gear tray. Here is a light similar to that one. You can still see it has vents that allows the air to go across it to keep it cool. So most importantly, and I can show you this up on the screen now, heat sinks and heatsink shape and heatsink finish all have a factor on maintaining the longevity of the LEDs, making sure the LEDs are kept cool, making sure they're all efficient, and everything else that it can possibly do. And also allows you to go and grab it while it's on, because it keeps it cool. That's what they look like. So top left is our one box 2030. It has a very, very big finned heatsink because it's a high output light. Down in the bottom left hand corner, or we have the Mr. Multi. It's a plastic fitting, but inside and around the LEDs is all aluminium. We have a major heat sink there. That's a gear tray heat sink. Then we have our one box, or our MR10. You can see the heat sink, it's very similar to this. It's the same height as this, okay? But it's really efficient. But two of those have remote drivers, and the one in the Mr. Multi is the only one that has a driver on board. All right, they're just examples of some heat sinks. They don't have to be all look the same. They all have the same, they're all as efficient as each other, but they're all designed differently.